Good morning, Calculus 1 students. We are at the end of Chapter 5. This could be the last video or two coming up here for this course. The topic is 5.8, inverse trig functions and integration. So there is a section 5.9 that we don't cover. So this is the end of the course. This is the end of the Chapter 5. 5.8, inverse trig functions and integration. So I wrote some stuff on the board here. Let's see if you can recall a few things. Back from Chapter 3, the derivative of arc sine was this pattern. The derivative of arc sine of x was 1 over the square root of 1 minus x squared. And, and maybe you recall that the derivative of arc cosine of x was negative 1 over the square root of 1 minus x. So same pattern, but the arc cosine was negative. So that was true with arc tangent. It had a pattern, a rule, and arc cotangent was the negative. Arc secant had a rule, and the arc cosecant was the negative. These were the derivative rules for these 6 inverse trig functions. You know, I never made you memorize them at the time, so when I say, do you remember this? Maybe you don't remember it. But these were the rules, and I don't want to write all the other ones. What we're doing now, though, is, of course, we're doing antiderivatives. We're going to try to integrate. But so when I integrate this, look at this. When I integrate a 1 over the square root of 1 minus x squared, the pattern it takes me back to arc sine of x. Or I could say it takes me back to the negative of arc cosine of x. I could say it's the negative of arc cosine of x, but we don't. So we choose this one, by the way, plus c. So you know, technically there could be 2 correct answers here, but we choose to go with this answer, and that's for this very basic 1 over the square root of 1 minus x squared. Now the truth is, here's where 5.8's rules kind of start. So I'm previewing the concepts here, but the rules kind of start here. Because what we do is we don't always have just a 1, and we don't always have just a boring old x. So what the rule here is I could have any number here, and the a represents a number, and I could have any function of x, and the u represents a function of x. So in other words, the pattern of a 1 minus x squared is generalized to an a squared minus a u squared in a square root in the denominator with a number on top of 1 on top with respect to u. So maybe you understand that? This has been generalized to any number a squared and any function of x u squared. And when it is, then the answer is the arc sine of u over a plus c. The other pattern then is this, with no square root, a general a squared plus a u squared. So you got to remember, a is a number, a constant, no variable, and u is the expression that contains the variables. And anyway, you integrate with respect to u, this pattern a squared plus u squared, no square root, and that's arc tangent. 1 over a, arc tangent u over a plus c. That's this new pattern, last 3 rules to memorize for this course. The integration of a 1 over u out in front of the square root, u squared minus a squared, that's, notice that subtraction is the opposite of this subtraction, so it matters with subtraction, it matters. With addition, those could be in any order, of course. But anyway, plus it has this u out here. Anyway, that's the arc secant pattern. 1 over a, arc secant, u over a, and we put this u in absolute value for arc secant. I guess we want to guarantee its positive slope. Anyway, cool. 3 new rules. And there's only 3. There's not 6. Okay, that's the idea. One of these, you don't have to. There's not 6. There's just these 3 patterns: arc sine, arc tangent, and arc secant. So we don't need an arc cosine answer, an arc cotangent answer, or an arc cosecant answer. They come from the negative of these, or I could just make these negative. So that's cool. Cool. 3 new patterns. So then I have one example here. So looking at this one example, you know, look at the pattern, look at the denominator, look at the pattern. What does it look like? Which one is it? Well, To me, it looks like an a squared minus a u squared. It's a number. It's an a squared minus a u squared. There happens to be a 5 on top. That doesn't bother me. I pull that out front, of course. So, sorry, I'll pull the 5 out front. And so if it's this a squared minus u squared, then I guess it's arc sine u over a. Now, so technically, what is the a then? Let's identify. If a squared is this 9, a is a 3, of course. If u squared is this 4x squared, then what's u? U is a 2x. Some students get confused for some reason, but that's basic algebra. That's the a squared. Please identify a. That's the u squared. Please identify the u. And so the answer would be, with the 5 out front, you pull the 5 out front, I guess it's the arc sine of u over a. Now the truth is, I want to show you something. Here I am, arc sine u over a, 2x over 3 plus c. So there I am, using this rule, using this pattern, but I made a mistake. And I wish it'd be so awesome if you knew or could figure out what that mistake was. There's a little mistake. I'm going to stand here for 20 minutes until you figure it out. Nah, I'll tell you. So, technically there was a little u substitution going on in this problem. And if you let u equal 2x, then what should you do to I sort of did this quickly in my head and I made a slight mistake. I should find du. And every time you call something u, you should find du. The only real exception is if you think u is an x, then du is just a dx and nothing interesting happens and you probably don't make a mistake. But when u is a 2x, du is a 2 dx. And therefore, when I replace this, the dx gets replaced with a 1/2 du, right? The dx is a 1/2 du, and the result is a 1/2 gets spit out in front of this. So, I tried to teach a u substitution really well back in the previous sections, 5.5, 5.7, and then and here we are in 5.8, and when there's a little u substitution going on, you carry through, find the du. The result is it spits out a 1/2, and so if you don't mind, I'll go over here. It spit out a 1/2 from a u substitution. It spit out a 1/2 from the u substitution process. Cool, we're done. I can do plenty more examples, but I think I'll pause there. I'll do some more difficult examples as we proceed. But you can jump up into 5.8 and try some homework. Look for a last assignment coming up. The last assignment will contain more than 5.8. It'll have some 5.8 and it'll have some other chapter 5 ideas, and that'll be about it for this semester. Thank you. Do some homework.